So now let's shift gears a little bit and talk about the hype surrounding GPUs. So first of all, how fast are GPUs? Let's take a look at the performance numbers. So these are peak performance numbers. So we're going to look at single precision gigaflops. Again, this is peak. And we're going to compare three architectures: high-end Intel Xeon CPU, high-end AMD GPU, and a high-end NVIDIA GPU. Let's take a look at what we've got here. Well, the Intel Xeon, it's about 333 gigaflops of performance that it can punch out. Compare this to AMD. AMD is at 4,000. It's a 12x performance increase over the Intel Xeon. That's phenomenal. Now look at NVIDIA. NVIDIA is not quite as good, but it's still 11x better than the Intel Xeon. So that's really fantastic. Now let's take a look at power. So if we look at the number of watts these things burn, so the Xeon's here is about 120 watts. That's not a little, but it's not a huge amount. AMD's at almost 300 watts. So 2.5 times as much power for that device. And NVIDIA is better than AMD, but still a lot worse than Intel, 2 times the power loss. So if you look at the performance and the power here, we can see that we're up to 12 times faster and at 2.4 times the power. So when you see these numbers, you should be thinking, gee, that looks like a good trade-off. 12 times faster, 2.4 times the power. It's not 12 times faster for 12 times the power. It's 12 times faster for only twice the power. That's not looking bad. And in fact, if we back up for a second and look at efficiency, what we see here is that the AMD devices are about 5 times as efficient in terms of gigaflops per watt as Intel Xeon. And NVIDIA is a little bit better even. And this is really the metric that's most exciting. And the reason for this is longer battery life, primarily. If you look at how much of computing these days is mobile computing in cell phones and laptops and tablets, getting 5 times the energy efficiency is tremendous. If you can get your application to use these devices, you can run 5 times as longer. But it's not just that, it's also lower total cost of ownership. So if you look in a data center, big cloud processing facility today, most of their cost is in energy and cooling. If you can figure out how to use these devices for data center processing, you could get your cost for cooling and energy down by a factor of 5. That would be tremendous. And finally, you get faster at a fixed power. If I want to get 10 times the performance here, I can't afford the power to spend 10 times as much on my CPU. But if I go over here, I actually have a more efficient architecture, and that more efficient architecture allows me to get better efficiency for my power. So if I have a fixed power budget, with this architecture, I can get better performance. So let's take a look at this in a little bit more detail. Those are peak numbers. Now let's look at real double precision matrix multiplication. So here's single precision gigaflops, and then here's what we get when we look at the double precision effect, or you actually get. So these are the numbers from before, and if we look at what we actually get when we do matrix multiplication, as opposed to the peak of the processor, we see the Xeon loses about half its performance. AMD loses a huge amount of its performance, over 3/4, going from single precision to double precision real versus peak, and NVIDIA loses about half their performance. So, or more than half their performance. Not great. So we're going from about 12 times faster to 7 times faster. Not so great. Now let's take a look at the efficiency here. So here's the efficiency in gigaflops per watt, and this takes a real hit. So before, when you were looking at peak, AMD had an efficiency that was 5 times higher than the peak on Intel. Now when we look at the real throughput of these things, it's only 1.7 times faster. It's nearly twice as good, but it's not nearly as much better as it was before, and NVIDIA is around 3.6. So this 5.4 times number is now down to something closer to 3.6. Let's take a look also at how much these architectures lose in efficiency. So here again, here are peak single precision numbers. Here are the peak double precision numbers here. So you see that Intel, when it goes from single precision to double precision, loses half its performance. AMD loses 3/4 of their performance when they go from single precision to double precision, and NVIDIA loses somewhat over half. Now let's see how much of that they can actually take advantage of. So Intel takes advantage of almost all of that. So if you're writing matrix multiplication here, you really can get most of the performance of the architecture. Same for NVIDIA. You get almost all of the potential peak performance. But in AMD, this is different. You get just barely over half of the potential peak performance. So what this is telling you is that the AMD architecture, while it has a much higher peak performance, when you go to do something real, well, if you consider matrix multiplication real, it's much harder to get that performance on that architecture.